The recent years have witnessed a dramatic increase in the use of reinforcement learning models in social neuroscience. This approach, in combination with neuroimaging techniques, enables quantitative investigations into latent mechanistic processes. However, increased use of relatively complex computation approaches has led to potential misconceptions and imprecise interpretations. To bridge this gap, we wrote a tutorial piece, and it was recently published in the journal of ESCAN. My name is Lei. In this short video, I will focus on the interpretation of the so-called learning rates in the simple Riskler-Wagner model, and other interesting topics can be found in our paper. The reinforcement learning framework, in essence, describes how learning emerges using feedback. In other words, how the difference between the actual feedback and the expected feedback, i.e. prediction error, is employed to update expectations. In the simple Riskler-Wagner model, the learning rate quantifies the amount of prediction error in the process of expectation updates. Importantly, a reorganization is necessary to examine the role of the learning rates. In particular, larger learning rates considers only the most recent outcomes, while smaller learning rates indicates long-lasting outcome effects from trials even in the past. Which learning rate is more optimal, namely leading more correct choices, depends heavily on the task design, for example, the reward ratio or the number of trials and so on. Lastly, we always recommend running simulations to understand the meaning of model parameters, and more details can be found on our GitHub repository. Thank you very much for listening.